In this video, we will learn the orthographic projections of circular lamina. Circular lamina is like a circular plane which we will place it in the first quadrant. So we will draw the first angle projection. So this is how the lamina can be placed, and lamina is circular lamina with its center 60 mm in front of the VP and 30 mm above HP, and the lamina is making an angle of 45 degree with HP. So first we locate the center of the lamina and draw the projections of the center of the lamina in the first angle projection. So we are in the first quadrant, and the top view of the center will be shown on the HP, and the front view of the center will be shown on the VP. So this paper is used as the VP. And the lamina is tilted at 45 degree to the HP, so we will show it later. So we start by drawing the projections of the center of the circular lamina first. Let's draw in freehand sketching. So this is the reference line XY. We locate the center in the top view, so it is 60 mm below the reference line, and the front view of the center will be shown above the reference line. We are drawing it at 30 mm above the reference line. So as a first step, we imagine that the lamina is parallel to the HP and perpendicular to the VP. In the second step, we will rotate the lamina with respect to the HP by 45 degree angle while keeping it perpendicular to the VP. So thinking that the lamina is parallel to the HP, the top view will be its true shape. So 60 mm diameter circle is its top view, and the front view will be a line because this lamina is perpendicular to the VP. So in the front view, we will see it as a line of dimension 60 mm, which is the diameter of the circular lamina. Now this circular lamina is to be tilted by 45 degree to the HP. So even after tilting, the front view will be still a straight line, but tilted 45 degree to the reference line. So it will be like this. So we will draw it at a new place, the front view. It is 45, it is making 45 degree with the reference line or with the HP, and the dimension of the front view will be the true diameter of the circle. Now for the top view, we extend the projection lines. So projection lines from the two edges and the centers. Projection line of the center will be the center line. So this is the location of the center of the circular lamina. So these are the two edges. We call it 1 and 7. So these are the two edges, and the upper edge will be, one is here and another is here. So as you can see that the projection of this circle will become an ellipse. The major diameter of the ellipse will be same as the diameter of the circle, but the minor diameter will be smaller in dimension. Now it is difficult to draw an ellipse with only 4 points, So what we are going to do is to divide this circle into 12 equal parts. By dividing, we are trying to find several points so that we can follow the points while drawing the projections. So these are the points from 1 to 12. And we project these points to the front view so that we know where are these points in the front view. So this is 2 and 12, 3 and 11, 4 and 10, 5 and 9, 6 and 8, and the last point is 7. So we identify those points in the front view, which is tilted at 45 degree. So we should use the compass and measure each length and locate those points in the front view. After this location, we draw the projectors. So projectors from the front view and projectors from the top. Now what we are going to make is like a grid, and within this grid we will identify the ellipse. So each point should be identified from the top view and the front view. All the numbers need to be followed carefully so that we can construct ellipse using these numbers. So we have made the orthographic view of circular lamina, which is 45 degree inclined to the HP. Now we will draw the same orthographic views on a drawing sheet. So we have drawn a center line and located the top view of the center of the lamina. The front view is above the reference line. So in the first step, we assume that the lamina is parallel to the HP, so we draw a circle as the top view. The lamina is perpendicular to the VP, so the front view will be a straight line of length equal to the diameter of the circle, which is 60 mm here. Now we move on to the second step, in which we are going to rotate the front view. So we will tilt the front view by 45 degree with the reference line. This is because the lamina is inclined at 45 degree with the HP. So this is the final front view of the lamina inclined at 45 degree to the HP. Now we will divide this circle into 12 equal parts so that we can follow each point for the projections for top view. So we have divided the circle into 12 parts and marked each part as number 1 to 12. Let us draw the projections first to the front view so that we can follow those numbers. So these are 2 prime, 12 prime, then 3 prime, 11 prime, and so on. Now these numbers or points should be transferred to the front view, which is tilted at 45 degrees. So we can use the compass and measure the length. Again we will mark the numbers. Now we draw the projectors from the front view and the top view to find out the final top view. First the center line so that we can identify the center of this ellipse. So now we identify those points. So for example, point 1. These are all intersections from the front view and the top view. Point number 7, point number 2, this will be point number 12, and so on. So all the points have been identified. Now we can join these points by freehand, making an ellipse. So now using 12 points, it is easier to form an ellipse than using only 4 points. This is the advantage of dividing the circle into 12 parts. So now this circle has been tilted by 45 degree, and this is the projection. After this, we should dimension all the dimensions which have been given in the problem. We do not need to dimension any projected lengths. This is the diameter of the circle. We can also dimension the tilted angle, that is 45 degree here. So for the notations, we will follow the final top view as 1, 1, 2, 1 and so on, and the final front view will be 1, 1 prime, 2, 1 prime and so on.